Okay, problem number 2. So, draw and explain the characteristics of 3 distinct steps in the free radical polymerization of ethene. Now, it's asking for just free radical, and that's all you need to write on your tutorial, but I'm going to go over ionization as well as condensation, just to be clear. So, the 3 steps. First of all, with addition reactions, we're dealing with alkenes being reacted. So everyone starts with an initiator. How do you get an initiator? Think about it for a second. Okay, so ways you can get your initiator. You can get it thermally, so you have thermoinitiators. That is, you've heated up to create either that free radical or ion. You have UV light, right? So a light to generate a radical, and I believe there is a third one, redox reactions. So these are the 3 ways to get an initiator. And basically, what an initiator does is it starts the reaction. So let's say we have R, whatever R is, and our initiator, because of heat or light or something, it's been changed in a way so that it has just this one electron instead of a stable lone pair. So it's a free radical. Now it's going to react with, let's see, with my alkene, whatever this guy is. Now, you can look at this as a double bond. You can also visualize that this, both of these bonds are sharing 2 electrons. So let's draw out the 2 electrons of that double bond. And what happens here is that this free radical electron can bond with one of these electrons. And they can form a nice little bond. So let's see what that looks like. Alright, so these 2 electrons have now come together to form this bond, but there's this electron left over. There's this guy. And now the radical component of the molecule has been moved over here. And now this can serve to initiate the next step in the chain growth reaction. So this was your initiator, but now that it has initiated the process, the alkene itself is now the reactive part. And this whole thing is called the initiation step, right? So what happens after initiation? Well, basically, you keep doing the same thing. This gets to keep growing. So there's another alkene here. And again, this bond consists of 2 electrons. It's reacting with one of them to form a bond, and this other one is going to be left over as an activated site to continue the process. So now we have, actually, let's move it over so I can draw it nice and big. Has the radical to continue the chain growth. And this step is called propagation. Right? I'm propagating it. I'm continuing it. And this step can go on indefinitely, right? However long you want your polymer to be. So those are the 2 steps, initiation, propagation. Finally, you want to end this free radical business. I'm going to switch this so it's easier for me to write. Alright, you want to end this free radical chain reaction. So you want something that has the radical but isn't going to continue the reaction. You want that starting material. Right, and now it's going to form a bond, but it doesn't have another bond. It's not going to have a leftover electron hanging out. So when this occurs, You no longer have a free radical on this molecule. It is stable. It is done. This is called what? Termination. Okay? So initiation, propagation, and termination. Now, you can do the same thing, basically the same thing, except instead of using a radical as your initiator, you can use an ion. And you can use either a positive or negative ion, right? Either an anion or a cation. So let's look at that. For example, so through the same process, you generate, or through a different process, let's say dissolving your salts or something, you get an ion. This, or let's say. Okay, and here I have an anion and a cation. They can both do the same thing. The reaction will just be a little different. So let's say I'm reacting it with this alkene. In this case, right, this is where that negative is, or where the electron density is. So this is the attacker. This is the nucleophile. This is what attacks things. It'll attack this carbon here, and it'll push an electron onto that carbon here, right? And so in this case, I will then generate, complicated, 1, 2, 3, 4, 1, 2, 3, 4, another bond, and then this guy, and then this guy. Except that here, now I'm going to have a negative charge. And that negative charge is going to continue the reaction, right? And in a chain-wise fashion. Here, this one is more electron dense than this guy, right? Because this is a positive charge. So in this case, this is the attacker. This is the nucleophile. And it's going to attack this positive carbon. And in turn, create, let's see. Bond there, then that, what was formerly a double bond, and then this R group. Right? And now this carbon is positive. So this guy is going to initiate the reaction with the next alkene, and so on. So, similar reactions, just different ones with the nucleophiles, because one is more negative than the other. But similar, you have your initiation, your propagation, your termination. Same as with the free radical reaction. Now let's just go over condensation as well. Now remember, this is an entirely different reaction. It's not part of the addition group. It's condensation. This is a step growth. And you also aren't reacting with alkenes necessarily. You're reacting with any functional group, 2 or more functional groups to be exact. So let's look at this guy. Plus okay? Now what's going to happen when these two react? You have it in some solvent, of course. The solvent is always important. And let's have this solvent have around hydrogen atoms just failed. Maybe it was sulfuric acid or something. Okay, and so the oxygen, which has lone pairs, is the nucleophile. It has more electron density. It's going to attack this positive guy. Okay, and then it's going to create, I'll just draw it under here. And I'm going to flip it so that this is now on this side. Right? And now this oxygen is positive, and we want to make it not positive because it's not stable that way. So this is actually going to be your leaving group. It's going to take an electron from here to stabilize your oxygen. Okay, so in the reaction, we draw that as H2O leaving, and then creating your product, which is, oh, I guess I haven't shown that yet. Okay, so this is where H2O leaves, the leaving group. It's now off on its own as a stable water molecule. And what we have now